Hello everyone, in this session we'll be running the different branch instructions on Keil and we'll see how exactly it works. Okay? Okay, first two instructions, what are they doing? They're loading R0 and R1 with same values, okay, which is nothing but 5. Next we are trying to compare these two values. Okay, are they equal? Yes. So what will happen in case of comparison? Subtraction happens. Result will be 0. Because of which we know that CPSR content will be updated. Which of these flags will be updated? Z flag is immediately set as 1 because the result is 0. What about carry? Carry will be 1 because any borrow is not generated here. Okay, and what about N and V flag? They will be 0 because the result is neither negative nor any overflow is generated. Now what we have is branch, but branch with some conditions. Okay, first thing we see is equal, next we have is not equal. So what will this equal check? It will check whether Z is 1. In this case, Z is actually 1, because of which this conditional code is true, and hence this branch will occur with the label specified here. What label do we see here? It is equal. If you notice here, it is written branch if equal to this particular address. What do you think is this address? Address of the very first instruction which comes under this particular label. Okay, let's see if that is true. Okay, what is the first instruction under this particular label? BL followed by addition. As you can see here, its address is nothing but 14. Okay, and that comes under the label equal. So what is this? This is branch with link. What does it mean? It means jump to this particular subroutine. Addition is the label of the subroutine. So as soon as you encounter BL followed by any label, what do you think will happen? Very first thing is PC is updated with this particular address, that is 28, because 28 is the address of this label which points to our desired subroutine. Okay, and one more thing that happens is link register will be updated with this address, that is address of the next instruction in this particular sequence. Let's see that happening. Yes, okay, so both link register is also updated, PC is also updated. Fine. So right now we are pointing into the very first instruction under our label addition, or in short, we are pointing at the desired subroutine. So what is happening here, or what we want here? We want to add R0, R1, and the result we want to store in R2. So what is R0, R1? We know it's 5 and 5. Result 10, hexadecimal A is stored in R2. Let's see that happening. Yes. Okay. Once this is executed, we are using BXLR. What should happen with this statement? Very first thing that should happen is whatever data is there in LR should be copied to PC so that we can return back to the next instruction to be executed. One more thing, it will check if the LSB of LR is actually 0 or 1. 18, when you write in binary, the LSB bit is actually 0. Okay, it's obviously an even number. So in binary, last digit will be 0. Okay, but if in case last bit is actually 1, it will assume you have to return back to thumb code. But now because it is 0, it will return back to ARM code. This is 18, and when you write it in terms of 32-bit value, all the next bits here will be 0. Okay, so because it is 0, obviously return will be to ARM code itself, or CPU will be in the ARM state and expects to execute ARM code itself, so there is no problem. Let's see the next set of steps. It is branching here, the exact spot that we were expecting, and this is branching to end program. As you can see, this doesn't have any condition. This is an unconditional jump to the label end program. Okay, fine. And what is this? This is again an unconditional jump happening, which is nothing but an infinite loop because it keeps jumping to the same spot. Okay, as you can check here, it is 3C branch to 3C only. Okay, so one thing which I want to show is what happens if here it was 18, right? Okay, and the last bit was 0. What happens if I modify the content of LR so that the last bit is set as 1? Let's see what happens then. As you can see here, I'm forcing the value of LR. In our case, we are writing fully ARM code, but just to show that it expects thumb code, I'm just forcing the LSB bit of LR to be 1. Okay, how am I doing that? I'm adding 1 to this, means the result is not 18 but it is 19. And how do you write 19 in binary? The last bit will be 1 here. Okay, let's see what happens in that particular case. Okay, these steps remain same. Okay, all comparisons happen and we are branching to equal. Here we are branching to our subroutine labeled addition. Here, if you check, T bit is actually set as 0. Okay, but once you finish all the execution and when you try to return back here to LR, which was previously incremented by 1, that is LSB set as 1, you will notice that T bit will be modified. So here the first step is same. I'm adding, okay, I have the same result, but what I have changed, I have purposefully modified the content of LR. If I don't modify it, it will retain the address of the next instruction we expected that time, but now I'm incrementing the value by 1. Okay, so what will be the LR content? As we expect, LR is now 19. Okay, and obviously last bit is 1. So what happens here? So when first thing what happens is LR content is moved to PC, but one more thing you will notice is even when LR content is moved to PC, 19 is not the value moved, 18 will be the value moved. Okay, it will not consider the last bit. Okay, while loading the address there, it will consider the last bit only for ARM thumb mode switch, or to know whether ARM thumb mode switch is required or not required. You will see that now. Okay, so as you can see, PC content is now 18, not 19. Okay, it will always assume last bit as 0 for address, but in order to know whether it should move to ARM mode or thumb mode while returning back, it will check the last bit. As you see here, T bit is now 1. So it has returned to the same address. Okay, and if I try to execute it, you will see an issue here, undefined thumb instruction at 0018H. Why is that the case? Because it was actually expecting thumb instruction and it got ARM instruction. What do you mean by the expected thumb instruction? Thumb is a 16-bit instruction set, whereas ARM is 32-bit instruction set. Here it will be fetching just 16 bits from the memory and it will misinterpret the given instruction as something else. Okay, so because of which you can see unpredictable behavior here. It's going somewhere here and all. Okay, one additional thing which I want to show is, so here values are 6 and 5. Of course these values are not equal. So which of this particular instruction will be executed? Now we know as soon as this comparison are carried out, internally subtraction happens. Okay, R0 minus R1, and because of which these CPSR registers will be updated. And what should happen once the subtraction is carried out? First thing that happens is Z flag will be 0 here, because of course these are not equal, so Z will be 0. Negative will be set as 1 if first value is less than second value. Carry will be 1 if first value is greater than second value, and overflow will be equal to 1 if overflow is generated. So in this particular case, carry should be set as 1. Let's see that happening. Okay, so now which of this particular condition is true? Of course, not equal is true. Okay, so the first instruction will be ignored and next instruction will be executed. That is, this branch will occur, and where exactly it will branch? It will branch to a label called not equal. If you notice here, this instruction here is actually branch if not equal. This is the address associated with the label not equal. So let's see what happens when we execute that. Okay, the instruction we have is branch with link and to which particular label? Addition to. Okay, this is the name of the subroutine which we need to execute now. And what is the CS? It's a conditional code. Only if carry is set, then branch with link operation is to be carried out to this particular label. Let's see what happens now. Okay, so we have reached this particular spot, and what is happening here? We are supposed to just perform addition. Okay, R0 content is supposed to be added with 3. So R0, what is the initial value? It is 6 plus 3 is 9. So the value 9 should be stored in register R2. Yes. Next, what we want to perform? See, this step I have additionally added. In general, we directly go with BX followed by LR. Then we know that it will return to the next line of the previous code which was getting executed. But in this case, I'm trying to show that we can use any register here. It need not be only register R14, which is our link register. So what I'm doing here is, I'm adding link register content with 4. So what should that actually do? If you notice here, the link register content is pointing at address 20. So what is stored at the address 20? If you notice, it will be nothing but this address. Okay, this is address 20. If I add plus 4 to that, which instruction do you think control should move to? It is this address, because 24 is actually this particular address. How did I know it 24 is this address? Every instruction is 32-bit. So 20 plus 4 is 24. Okay, that's why this is the instruction supposed to be pointed. Let's see if that is true. Okay, so that address is updated in R4, and now where will we return? We are returning to this particular instruction. Okay, so what happens here? Here what we have is R5 content is now updated with 6. So those were few things you needed to know about branch with condition, branch with link, and branch and exchange.